So 2008 BC2 is another one of those tabular data problems in which we're given information about a certain function. That certain function is L of t, the number of people that are waiting in line at any certain time from t equals 0 to t equals 9. So they're trying to sell concert tickets, and it just so happens when they start the clock there's already 120 people waiting in line. Okay, at the end of the 9 hours, so this actually starts at, starts at noon, right? Yeah, so noon is t equals 0, and then 9 p.m. would be the t equals 9, and the tickets get sold out at 9 o'clock, or by 9 o'clock, so there's no more people waiting in line at 9. So understanding what's going on is really helpful. It's asking us, first of all, in part A, to estimate the rate at which the number of people waiting in line was changing. So if we want the rate of change of something, then we're going to find the slope. Okay, and the only slope we can find would be the slope of the line segment in between 120, this 126 and the 150 mark, and that's why slope of the line would be average rate of change in between t equals 4 and t equals 7. And so again, we can easily find the slope of that line. Just take the y2 minus the y1 over the x2 minus the x1, and then we get 8. So 24 divided by 3 is 8, and that would be people per hour, and you want to make sure you write that. So that's part A. Part B is asking us to find the average number of people waiting in line. So the hard part about this is understanding what is being asked. If you want to find the average number of people waiting in line, then you have to figure out what function are we looking for. Well, L of t represents the number of people waiting in line, and if we're trying to find the average number of people waiting in line, then we're trying to find the average value of L of t. Okay, so the average value of L of t would be integral over interval. Okay, and the integral, we're using a trapezoidal approximation to find that, or to approximate that, and we just add up the areas of these three trapezoids from 0 to 4, and the interval would be 4 minus 0. Okay, so you can see the work down here for part B, down here at the bottom of the page, and that would give us, and you can leave it like that, that's going to be the number of people that was the average number of people waiting in line at any one time over those first 4 hours. So 155.25 people waiting in line on average. Okay, at least that's an approximation for that. So that's part B. Part C was asking us to find how many times, what's the fewest number of times at which L prime of t must equal 0. So this goes back to the theorems that we learned the other day about the intermediate value theorem is the thing I think would be the easiest way to write this answer. There's a couple ways listed in the AP answer key. But if you look at it like this, if you just draw a picture, like I drew a picture and so I could visualize it, I can see that it's going to be 3. The key is trying to explain that. To get from 120 to 176, I know that L of t must be climbing, and L of t climbing or increasing must mean that, or means that somewhere in that interval L prime has to be greater than 0. Okay, and therefore we can use the same reasoning that at time 3 here at 176, and at time 4 you're down here at 126. You're up here and then down, so up to down means you're decreasing on that interval, so therefore L prime has to be negative somewhere on that interval. And so on the interval from 0 to 4, somewhere in there L prime must be equal to 0, because the intermediate value theorem says that if L prime goes from positive to L prime negative, then somewhere in there it's going to be 0, because it takes on all values in between the L at 0 and L at 4, and or L prime I should say of 0 and L prime of 4. Again, L prime going from positive to negative. And likewise, from 3 to 4 negative to 4 to 7 positive, L prime changes from L prime changes from negative to positive, and therefore we have another horizontal tangent line, or another L prime equals 0. And then from 4 to 7 to 7 to 8, L prime changes from positive to negative, therefore L prime must be negative, or sorry, equal to 0 somewhere in there as well. So in other words, we have 3 places from 0 to 9 in which we're guaranteed we're going to have L prime equaling 0, and that's the fewest number of times. Could have more, but you can't have less, and that's the answer, 3. and that's the reasoning. And finally, part D, we know the rate at which the number of, what is that? The rate at which the tickets were sold. We know the rate at which they were sold. We just want to know the number of tickets that were sold. And if we know the rate and we want the number, then we have to back up. We have to integrate from 0 to 3, gives us the integrating from 0 to 3 of the rate gives us the number of tickets that were sold from 0 to 3. T equals 0. That's from noon to 3 p.m. Okay, so 973, as you can see, tickets sold by 3 p.m. There you go.